What if I told you that there's enough water in Earth's oceans to cover the entire planet's surface to a depth of 1.7 miles? What if I told you that if you could somehow flatten every mountain, fill every valley, and make Earth perfectly smooth, you'd be living on an ocean world where the deepest point would still be over 8,000 feet underwater? But here's the mind-bending question. What would happen if we didn't stop there? What if something catastrophic melted every glacier, every ice cap, every frozen drop of water on Earth? What if rising sea levels didn't stop at coastal cities, but kept rising until there was no land left at all? Welcome to Space Prime. I'm your host, and today we're running the ultimate thought experiment, transforming Earth into a complete water world. We're going to flood every continent, submerge every mountain peak, and explore what life would look like on a planet where the ocean floor is the only solid ground left. Prepare to dive into the most extreme climate scenario ever imagined, the Great Melting. Let's start our simulation with the event that would trigger Earth's transformation into a complete water world. We're not talking about normal climate change here. We're talking about a catastrophic scenario where every single piece of ice on Earth melts simultaneously. Right now, Earth contains approximately 24 million cubic kilometers of ice. That's locked up in Antarctica, Greenland, mountain glaciers, permafrost, and polar ice caps. If all of that ice melted completely, sea levels would rise by about 230 feet worldwide. That would flood coastal cities and reshape continents, but it still wouldn't create a true water world. So let's push our thought experiment further. What if a runaway greenhouse effect, similar to what happened on Venus, began to occur on Earth? What if global temperatures rose not by a few degrees, but by 50, 100, or even 200 degrees Fahrenheit? At those extreme temperatures, something fascinating and terrifying would happen. The atmosphere would start holding dramatically more water vapor. For every degree Celsius of warming, air can hold about 7% more moisture. Push temperatures high enough, and the atmosphere becomes a massive reservoir of water vapor just waiting to condense. But here's where our scenario gets really interesting. What if this superheated atmosphere began pulling water from an external source? Imagine if Earth passed through a region of space filled with water-rich comets, or if multiple ice-rich asteroids bombarded our planet simultaneously. Suddenly, we're not just dealing with Earth's existing water, we're adding millions of cubic kilometers of new water to the system. Ocean levels wouldn't rise by hundreds of feet, but by thousands of feet, miles even. In our simulation, let's say this catastrophic event adds enough water to raise global sea levels by 29,000 feet, just high enough to submerge Mount Everest, the tallest point on Earth. The New World Ocean. Picture Earth from space after this transformation. Instead of the blue marble with brown and green continents that we know and love, you'd see a perfect sphere of deep blue water. No land masses, no ice caps, just an endless global ocean stretching from pole to pole. But this wouldn't be a shallow, uniform sea. Remember, we haven't actually changed Earth's topography. We've just added water on top of it. Beneath this new global ocean, the familiar features of our planet would still exist, now serving as an underwater landscape more varied and dramatic than any terrestrial mountain range. The Himalayan mountain range would become a series of underwater peaks rising from abyssal depths. Mount Everest, once the roof of the world, would now be an underwater mountain with its peak 29 feet below the surface, still the highest point on the planet, but now accessible only to deep-sea divers. The Grand Canyon would transform into an underwater gorge, deeper and more spectacular than any ocean trench. The Amazon basin would become a vast underwater plain, while the Sahara Desert would be a sandy seafloor beneath miles of water. But here's where things get really interesting from an oceanographic perspective. This new global ocean would have an average depth of about 1.7 miles, but the deepest points would be absolutely staggering. The Mariana Trench, currently the deepest part of Earth's oceans at about 36,000 feet deep, would now be nearly 65,000 feet below the surface. Over 12 miles of water above the deepest point on Earth. That's deeper than the cruising altitude of most commercial aircraft. If you could somehow sink straight down through this water world, you'd pass through pressure zones that would crush any known submarine long before you reach the bottom. The physics of depth. Let's talk about what these incredible depths would mean for the physics of our new water world, because the conditions down there would be more alien than anything we can find in space. Water pressure increases by approximately 14.7 pounds per square inch for every 33 feet of depth. At the bottom of our deepest ocean trenches, now 12 miles underwater, the pressure would be over 5,000 times greater than atmospheric pressure at sea level. To put that in perspective, that's like having the weight of 50 elephants pressing down on every square inch of surface. Any human body exposed to that pressure would be compressed to a fraction of its original size in microseconds. But pressure isn't the only extreme condition in our water world's depths. Temperature would also behave in fascinating ways. In normal oceans, temperature drops as you go deeper, reaching near freezing temperatures in the deep sea. But with water depths of 12 miles, our planet's geothermal energy would create some unexpected effects. The deeper parts of our global ocean would actually be warmed by geothermal heat from Earth's core. Underwater volcanic activity would create pockets of superheated water that rise through the water column, creating massive convection currents that would drive weather patterns unlike anything we see on Earth today. These convection currents would be so powerful they could create underwater storms, massive rotating systems of water moving at incredible speeds through the deep ocean. Imagine hurricanes that exist entirely underwater, with no surface to disrupt them, potentially lasting for months or even years. The pressure differentials between the surface and the depths would also create some bizarre phenomena. Sound would travel differently through these various pressure zones, creating acoustic channels that could carry whale songs or other sounds across entire ocean basins. Life in the deep. Now comes the fascinating question: what would happen to life on our new water world? First, let's be clear about what wouldn't survive. Most terrestrial life forms would be wiped out immediately. Land plants, land animals, insects, birds. Essentially, anything that depends on dry land or atmospheric breathing would be gone. We're looking at the most massive extinction event in Earth's history. But life, as we know from studying extremophiles, is incredibly adaptable. The survivors would be organisms already adapted to aquatic environments, and they would inherit an ocean planet with ecological niches beyond imagination. Deep-sea creatures that currently live in the abyssal zones would suddenly find themselves in a vastly expanded habitat. Giant tube worms, bioluminescent squid, pressure-adapted fish. These organisms would have the entire planet as their domain. But here's where evolution would go into overdrive. With no land-based predators or competitors, marine life would begin evolving to fill every possible ecological niche. We might see the evolution of organisms larger than anything that has ever existed on Earth. Imagine whales the size of cruise ships, no longer limited by food scarcity in small ocean basins. Picture jellyfish colonies that span thousands of miles, drifting through the global currents like living continents. Consider the possibility of deep-sea civilizations, intelligent cephalopods that build cities in underwater mountain ranges. The biodiversity in our water world could eventually exceed anything Earth has ever seen. Different pressure zones would become distinct evolutionary environments, creating life forms adapted to specific depths. We might see creatures that migrate vertically through thousands of feet of water, following pressure gradients like terrestrial animals follow seasons. Near the surface, photosynthetic life would still exist, but it would be entirely aquatic. Massive kelp forests could cover the surface of the entire planet, creating a global ecosystem that produces oxygen and supports surface-dwelling marine life. The civilization question. Here's the question that keeps me awake at night. Could an intelligent civilization develop on a water world? Human civilization, as we know it, depends on fire, metallurgy, and dry land for agriculture. None of these would be possible on our flooded Earth. But that doesn't mean intelligence couldn't evolve. It would just take radically different forms. Let's imagine that some population of humans survived the Great Flooding by developing advanced underwater habitats. Over thousands of years, these communities would face evolutionary pressures unlike anything in human history. They might develop enhanced lung capacity for deep diving, better pressure tolerance, improved underwater vision, or even biological modifications for extracting oxygen directly from water. We're talking about the potential evolution of an aquatic human subspecies. But more intriguingly, completely non-human intelligence might emerge. Octopuses and dolphins are already showing signs of complex problem-solving abilities. In a world where they have unlimited territory and no terrestrial competitors, their intelligence could develop in ways we can't imagine. An octopus civilization might build cities from coral and volcanic rock, using bioluminescence for communication and coordination. They could develop biotechnology instead of mechanical technology, growing their tools and structures from modified sea life. Dolphin societies might become the dominant intelligence, using echolocation to map and navigate their entire planet. They could develop forms of art, music, and culture based on sound and pressure waves traveling through water. Without fire or metallurgy, these civilizations would develop entirely different approaches to science and technology. Instead of chemistry and physics, they might master biology and pressure dynamics. Instead of building machines, they might genetically modify organisms to serve as living tools. Planetary changes. Our water world wouldn't just change life, it would fundamentally alter how Earth functions as a planetary system. The first major change would be in Earth's rotation and orbit. Adding massive amounts of water to the planet would increase Earth's total mass, which would affect our orbital relationship with the Moon. The Moon's gravitational pull on a global ocean would create tidal forces unlike anything we see today. Instead of tides that rise and fall along coastlines, our water world would experience global tidal bulges that travel around the planet. These wouldn't be gentle rises and falls of a few feet. They would be massive waves hundreds of feet high that circle the globe every 12 hours. The weather patterns on our water world would be absolutely spectacular. Without land masses to disrupt air currents, wind patterns would become incredibly regular and powerful. We might see permanent storm systems that circle the globe like bands around a gas giant. Hurricane-force winds could become the norm rather than the exception, with massive storm systems drawing energy from the unlimited warm water beneath them. These storms wouldn't be destructive in the traditional sense. There would be no buildings or cities to destroy, but they would create underwater currents and pressure waves of incredible power. The water cycle would also be fundamentally different. With no land to condense moisture, precipitation would fall directly back into the ocean, creating a more direct and efficient cycle. This could lead to more extreme weather events and more rapid heat distribution around the planet. Most fascinatingly, our water world might develop a completely different climate system. Without polar ice caps to reflect sunlight, the planet would absorb more solar energy. But the massive thermal mass of a global ocean might also regulate temperatures more effectively than our current land and sea system. The cosmic perspective. So what would happen if Earth became a complete water world? We'd be looking at a planet transformed beyond recognition, not just a different Earth, but essentially a different type of world altogether. From a cosmic perspective, our water world would actually resemble many of the planets we're discovering around other stars. Ocean worlds might be among the most common types of potentially habitable planets in the universe. By studying our hypothetical water Earth, we're actually exploring what life might look like on countless worlds throughout the galaxy. The fascinating thing is that a water world Earth might actually be more stable and long-lasting than our current planet. Water is an excellent moderator of temperature extremes, and a global ocean would be incredibly resistant to the kind of catastrophic climate changes that could threaten land-based civilizations. But perhaps most intriguingly, our water world thought experiment reveals just how unique and precious our current Earth really is. The delicate balance between land and sea that allows for both terrestrial and marine life, the moderate climate that keeps most of our water liquid, the complex interactions between atmosphere, ocean, and geology, all of these create the extraordinary diversity of life we see today. Our water world would be alien, beautiful, and teeming with life forms we can barely imagine, but it wouldn't be home, not for us anyway. What do you think would be the most fascinating aspect of living on a water world? The extreme deep sea environments, the evolution of aquatic intelligence, or the spectacular global weather systems? Let me know in the comments below. And if you enjoyed this deep dive into planetary transformation, subscribe to Space Prime and hit that notification bell for more thought experiments that push the boundaries of what's possible. Because sometimes the most interesting questions aren't about distant planets, they're about how different our own world could be. Thanks for watching Space Prime. Until next time, keep exploring the impossible.